During this tutorial session, I will show you how to use the intermodal transportation model proposed by INCL, Port of Monfalcone and SDAG as a contribution to VP4 of the Pixel project. In particular, this model is aimed at forecasting congestions of track that can happen at the port entrance and provide operators with the tools required in order to monitor such congestions, prevent them, and eventually reroute the traffic of the tracks to different locations, for example SDAG, in order to reduce the impact on the entrance of the Port of Monfalcone. The input used by the model in order to simulate and forecast the congestion are represented by four kinds of information. First of all, we have the list of ships coming to the port in the next few days and the kind of good that they will transport. In our model, every specific good is defined as something that has a flow impact on the port according with the different activities that are required in order to load and unload such kind of goods from the ship. We can have different kind of goods and everyone can have a different impact on the overall set of activities that take place inside the port. So the first set of information that we work on is the set of operation. So the list of incoming ships with an estimated arrival time, an estimated departure time, the name of a ship, a specific kind of good transported by the ship, and an amount of tons. Such amount of tons is used to evaluate the impact in terms of number of trucks and pollution that the different transportation mode can provide to the region and to the surrounding areas of the port. The second kind of information we use in our model is the set of data concerning the expected flow of trucks coming to the port, and in particular this data is provided by the SILI information system. The model automatically acquires the data and is able to identify and to forecast based on an average mean calculated on the last 6 hours the amount of expected trucks, the amount of unexpected trucks, so trucks that are reaching the port without asking for permission to enter. By using these two amounts, the model is able to forecast the amount of trucks that will reach the port at a specific time. By updating each of the rows presented in this page, model is automatically recalculated and updated in order to keep the new information in mind. The third kind of information is the availability of parking lot outside the Port of Monfalcone and the port and the area of SDAG. In particular, by asking for the availability of the parking lot, which is automatically provided by the access gate surveillance system and a set of smart cameras, so a set of IoT sensors, we can understand how many trucks are already waiting inside the parking lot and eventually which is the capability of the parking lot and how many trucks can be moreover hosted inside the parking lot before a congestion takes place. There's a fourth kind of input that we can use in our model, and this kind of input is related with unexpected events, for example snow or a traffic accident blocking the access to the highway, and such unexpected events can impact on the flow of trucks that the port is able to manage per unit of time. If we go to the home page, we can see that the model is recalculated. Such operation take place in a very small amount of seconds every time an information is changed by the user or by the information app. As you can see, we have 6 different graphs and charts in this dashboard. The first one is max flow. So it defines the maximum amount of trucks that can be served by the port according with the set of loading and unloading operations that are currently taking place inside the port. So for example, if a vessel is loading or unloading cars that occupies a very large amount of the port area, a smaller amount of trucks can enter the port or leave the port and be served for unloading and loading activities. The second chart is related with unexpected events flow impact, how such unexpected events can impact on the flow of trucks. And if I subtract from the max flow the unexpected flow impact, I have the effective flow, so the number of trucks that can be served by the port for each hour. If the status is red or green, I have an emergency I have to work on. The second column is related with the expected amount of trucks that the port is waiting. So in this case, we can see that during the different hours, a different amount of trucks is expected, and according with the new data coming from SILI, the forecasting of the expected amount of trucks can change according with the latest data, the latest available data. The second row is related with the expected occupancy of the parking lot. In this particular case, there's an emergency because most of the space in the parking lot is currently occupied, but as soon as the amount of trucks slowly goes down during the next few hours, we can expect that also the parking lot occupancy will become more and more higher. And when the parking lot occupancy is at the top, for example, in this point, we have a congestion. So there's an amount of trucks that cannot be hosted by the parking lot and will be stuck just outside the port because there's no available space and they need to reach the port in order to perform loading and unloading activities. Every time a change takes place on the data, for example, by introducing an unexpected event such as snow, data is automatically recalculated. So in this case, we have an automatic recalculation of all the data. For example, if I had a change the amount of expected trucks for the next few hours, for example, I change this value, and instead of 20, I can say that I expect 40. Now the data changes because it reflects on the expected amount of trucks, and even the parking lot expected occurrence changes, and the congestion will take place in a different way. So every time I change the data, I obtain an update of the model in real time. If I move from the congestion model to the multimodal model, I can see how, according with the amount of goods that are currently inside the port or will be in the next few hours, these goods can be transported by means of different transportation modes. For example, by using highway, by using fastway, or by using train. And for each of the different transportation modes, I can see the impact of such transportation mode in terms of pollutants, in terms of particles, and eventually also in terms of social impact on the surrounding areas.